Hello. Today we are going to see the problems based on continuity. The first problem is discuss the continuity of the function defined by f of x equal to x plus 2 for x less than 1 and x minus 2 for x greater than 1. So, uh, first of all, let me see the problem through graphical. Okay. Uh, this is x-axis, y-axis. I am going to draw the function graphically. So let us take this is minus 1, minus 2, minus 3, 0, 1, 2, 3 along x-axis, 1, 2, 3 along y-axis, minus 1, minus 2, minus 3. So when the x value is less than or equal to 1, the function takes x as x plus 2. Now let me start from equal to 1. When it is equal to 1, then replace x by 1. See here, you are going to do this function. When x is equal to 1, then 1 plus 2 equal to 3. Therefore, when x is equal to 1, you will get 3. Clear? The next is when x is equal to 0, that is less than or equal to 1, we are doing. Therefore, when x is equal to 0, 0 plus 2 is 2. When x is equal to minus 1, minus 1 plus 2 is 1. So when we are connecting this, okay, this is less than or equal to 1, therefore up to 1 it will go. Okay, then when we take x equal to minus 2, minus 2 plus 2, 0, therefore the function will go like this. This is the point. When x takes a value 1, y takes a value 3. When x takes a value 0, y takes a value 2. When x takes a value minus 1, y takes a value 1. When x takes a value minus 2, y takes the value 0. Now this one is over when x less than 1, less than or equal to 1. Now what about for x greater than 1? Let us take x greater than 1, that is x is equal to 2. So when x is equal to 2, the function will take the value x minus 2. Therefore when x is equal to 2, 2 minus 2 is 0. Therefore this is when x is equal to 2, y, the function value is 0. Then when x is equal to 3, the function value is 3 minus 1, therefore 1. Therefore when x is equal to 3, it is 1. So here the function will go like this up to 1 but not equal to 1. Here the 1, x is equal to 1, this line will hold. Here x, it won't meet x. So this is the graphical representation of that function. Now see here, it is very clear. You cannot draw the graph without take your hand, lift your hand. Therefore it is not continuous. See here, if you draw this diagram, you have to lift the hand. Therefore at where you have to lift, at the point x is equal to 1, you have to lift the hand to come at this point. Therefore clearly at x is equal to 1, the function is not continuous. Now how to show at x is equal to 1 the function is not continuous? By our regular method. So theoretically, so we are going to discuss the continuity of the function. So we clearly saw that the function is continuous at x less than 1 and x greater than 1, but at x is equal to 1 the function is not continuous, that is graphically. Now, so here if you see, the function is defined at all numbers of the real line. Clear? It takes all possible values in the real line. No value is omitted because x less than or equal to 1, 1, 0, minus 1, minus 2, etc. If x is greater than 1, it will take 2, 3, 4, etc. No value is missing. Clear? Now let's see any point on the real line. Now three cases arise according to this problem. C may be less than 1, or C may be greater than 1, or C may be equal to 1. So we are going to solve this problem by taking three cases. Case 1 is, let us take C less than 1. So limit x tends to C, f of x is equal to, what about for C less than 1? If C is less than 1, the function will take x plus 2. Therefore, for since x tends to C which is less than 1, the function will take x plus 2. Therefore, replace x by C, you will get C plus 2. So this is for limit of that function at C. Now what about f of C? F of C is equal to, since C is less than 1, it takes the value x plus 2. Clear? It takes the value x plus 2. Therefore, f of C will be C plus 2. Now see here, the condition satisfies, that is limit x tends to C, f of x equal to f of C. Therefore, the function is continuous at C less than 1, that is at all points less than 1. Now case 2. What about for C greater than 1? So limit x tends to C, f of x for C greater than 1, the function will take the value for C greater than 1, it takes x minus 2. Therefore, here the function will take the value x minus 2. When you replace x by C, you will get C minus 2. Now what about f of C? Since C is greater than 1, the function will take C minus 2. Now again see here, the limit x tends to C, f of C equal f of x equal to f of C. Therefore, again the function is continuous at x, that is C greater than 1, all numbers greater than 1. Now what about for case 3, that is C equal to 1? Okay, so here we have to go for left hand side and right hand side. Why? Limit x tends to C, we have to check f of x is equal to f of C. This is a condition for continuity. Therefore, left hand side limit x tends to C minus a value slightly less than C. So here C equal to 1. Therefore, the value slightly less than 1. So, for my convenience, I can write this as 1 minus a value slightly less than 1 f of x. Therefore, slightly less than 1 means x is less than 1. Therefore, automatically the function will take the value, since x is less than 1, it will take the value x plus 2. Therefore it will take the value x plus 2. Therefore replace x by 1, you will get 1 plus 2, which is equal to 3. Now what about the right hand side limit? Limit x tends to 1 plus, that is a value slightly greater than 1, f of x is equal to limit x tends to 1 plus. So for the values greater than 1, the function will take x minus 2 for x greater than 1. Therefore for the values greater than 1, you take x minus 2. Therefore when you replace x by 1, you will get 1 minus 2, which is equal to minus 1. But see here, LHL not equal to RHL. Therefore the limit does not exist at c equal to 1, that is x is equal to 1. Therefore the function is discontinuous at x is equal to 1. That is what we clearly saw through the graphical method. See here, at x equal to 1 there is a discontinuity. That is what we shown through theoretical way. Now the next problem is discuss the continuity of the function f of x is equal to x plus 2, x less than 0 and minus x plus 2, x greater than 0. See here the function is defined for all real numbers except 0. Why? See here, the function is defined for x less than 0 and x greater than 0, but there is no equal to 0 is there. Therefore I wrote here the function is defined for all real numbers except 0. But in the previous problem, if you see, the function is defined for less than or equal to 1 and greater than 1. Therefore it is defined at all numbers. But see here, in this problem it is defined for all real numbers but except 0. Now we have to check the continuity of the function. So let me take C be any real number which is not 0, because 0 is not defined in the function. Now so two cases arise, either c is less than 0 or c is greater than 0. Let me take case 1. If c is less than 0, then what about the limit? Limit x tends to c, f of c equal to, what about c is less than 0? It will take the function x plus 2. Therefore since c is less than 0, here f of x, clear. Therefore limit x tends to c, the function will take the value x plus 2. So x plus 2, when you replace c by x by c, you will get c plus 2. Now what about f of c? What is f of c? Since c is less than 0, the function is taking x plus 2. Therefore replace x by c, you will get c plus 2. Therefore the function is continuous at all numbers which is less than 0, continuous at c less than 0. Now what about the other case, case 2? So if c is greater than 0, then limit x tends to c, f of x is equal to limit x tends to c. Since c is greater than 0, the function will take the value, if x is greater than 0, minus x plus 2. Therefore here it will take minus x plus 2. Therefore when we replace x by c, you will get minus c plus 2. Now what about f of c here? Since c is greater than 0, the function is take minus x plus 2. Therefore f of c will be minus c plus 2. Therefore the condition satisfies here. Therefore the function is continuous at c greater than 0. Here no need to prove for c equal to 0, because c equal to 0 is not defined in this function. Therefore the function is continuous at all points except 0. This is a very simple problem based on continuity. Now the next problem, find the relationship between a and b so that the function f defined by f of x is equal to ax plus 1 for x less than or equal to 3 and bx plus 3 for x greater than 3 is continuous at x equal to 3. This is the function. So given the function is continuous at x is equal to 3, it is given. So if the function is continuous at x equal to 3, then what is the relationship between this a and b? That is the question. So the function is continuous at x equal to 3 means limit x tends to 3 f of x exists and it will be equal to f of 3. Now what about limit x tends to 3 f of x? So since the limit exists, LHL, we are going to find out limit x tends to 3 minus f of x, that is a value slightly less than 3. So since 3 minus means a value slightly less than 3, the function will take less than 3 means ax plus 1. Therefore here ax plus 1. When you replace x by 3, you will get 3a plus 1. Now what about the right hand side limit? So limit x tends to 3 plus f of x, the meaning is a value slightly greater than 3. So a value slightly greater than 3 means automatically the function will take the value, see, greater than 3 means it will take the value bx plus 3. Therefore it will take bx plus 3. When you replace x by 3, you will get 3b plus 3. Now see here, since the limit exists, LHL will be equal to RHL. Both LHL and RHL are same. Therefore 3a plus 1 is equal to 3b plus 3. 3b plus 3. Therefore 3a equal to 3b plus 2. Therefore a is equal to 3b plus 2 divided by 3, which is equal to b plus 2 by 3. sorry, a is equal to, therefore the question is you have to find the relationship between a and b. Therefore a is equal to b plus 2 by 3. This is the relationship between a and b. This is also a very simple problem. Now the next problem is, for what value of lambda is the function defined by f of x is equal to lambda into x square minus 2x for x less than or equal to 0 and 4x plus 1 for x greater than 0 continuous at x equal to 0, and also what about the continuity at x equal to 1? What is the meaning in this problem? If the function is continuous at x equal to 0, what will be the value of lambda? For what value of lambda the function is continuous at x equal to 0? Also the second one is, for what value of lambda the function is continuous at x equal to 1? Okay, solution. Let us take the first one. Let us assume the function is continuous at x equal to 0. The function is continuous at x is equal to 0. Therefore, it will satisfy the condition limit x tends to 0, f of x is equal to f of 0. So, let us find what is limit x tends to 0, f of x. Okay. So, see here, since the function is defined at lambda at x less than or equal to 0 and x greater than 0, and we are going to check for x equal to 0. If you are choosing a value slightly less than 0, it will assume lambda into x square minus 2x, and x is slightly greater than 0 means it will assume 4x plus 1. Therefore, we have to go for LHL and RHL. Since the limit exists, what about LHL? Limit x tends to a value slightly less than 0. A value slightly less than 0 means the function will assume the value lambda into x square minus 2x. Therefore, the function is lambda into x square minus 2x. When we replace x by 0, lambda into 0 minus 0, you will get 0. Now, what about right hand side limit? A value slightly greater than 0, the function value is, see here, for value slightly greater than 0, the function value is 4x plus 1. Therefore, here you will get the function value the function value 4x plus 1. When you replace x by 0, you will get 4 times 0 plus 1, which is equal to 1. Now see here, LHL not equal to RHL. That is, the limit doesn't exist, does not exist. That is the function is not continuous. But we started with the function is continuous at x equal to 0. Here we arrived that the function is not continuous at the point x equal to 0. Therefore, for any value of lambda, the function is not continuous at x is equal to 0. So this is the answer for the first question. Now one more question is there. What about the continuity at x equal to 1? Okay. So the second one, let let us assume the function f is continuous at x is equal to 1. Therefore, limit x tends to 1, f of x equal to f of 1. See here, for 1 is always greater than 0, therefore there is no need to find the left hand side and right hand side, because it will take, since 1 is less than 0, always it will take the function 4x plus 1. Therefore I am going to find the limit of the function directly. Hence limit sorry limit x tends to 1, f of x is equal to, since 1 is greater than 0, the function will assume 4x plus 1. Therefore limit x tends to 1, 4 times x plus 1. Therefore you will get 4 times 1 plus 1. By replacing x by 1, you will get 5. Now what about f of 1? So since 1 is greater than 0, again you can replace x by 1 in that function. Therefore again you will get 5. Therefore here f is continuous. Since f is continuous, we have proved that. But if you see here, there is no role for lambda playing here. Lambda plays no role. Therefore for any value of lambda, the function is continuous at x is equal to 1. So this is also a very simple problem.